Can you hear me? Yeah. So welcome everyone. Thank you so much for coming to our session in which we are going to show you what we wish we knew when we started with Lightning Components development. Let me first introduce myself. My name is Alba Rivas. I work as an architecture lead for Financial Force, and this is my email, my Twitter handle, and my blog in case that you want to contact me later. I'm also a Salesforce MVP.
Well, hi everybody, my name is Pedro Molina. I'm also working at Financial Force with Alba as a Salesforce developer. And in case you want to contact me, you can do it through my email, my Twitter account, or my personal blog where I talk about Salesforce. Well, as we said, we both are working for Financial Force. We are the #1 cloud ERP on Salesforce. We are also a Salesforce partner, a company with over 700 employees and with offices all over the world. In case you want to visit us, you can do it at kiosk number 2. All right. Since we started to learn Lightning Components, we attended to many sessions, webinars, workshops, in where somebody was explaining to us how to create a Lightning component. That was really, really helpful for us. But in this session, we want to go a step further and show you non-trivial tips we have learned with experience and what have been clarifying for us. And so those are the points we want to see today. And every time, the first thing is to set up the environment. For doing this, you will need to perform just 2 actions. The first one is to set the debug mode on. This will allow you to display JavaScript files unminified, and so you will be able to set a breakpoint or, for example, just have a look at the code. And the second thing is to set the cache off. This will allow you to go to the browser and check your modification of the code just by refreshing once the code. Okay. So now it's time for knowing the tools we can use for developing and debugging. Of course, you can use any IDE you like, but Salesforce's recommendation is to use Salesforce DX and Visual Studio Code. And this is not a Salesforce whim, all right? This is because Visual Studio Code, Salesforce DX, and Lightning are fully integrated. A really good trick is to use a Lightning resource as a wrapper called a standalone app. This is because standalone apps are URL addressable. And in this way, you will be able to go to the browser and quickly type the address of your application and see the modification performed. For debugging, the best tools are the Chrome DevTools. And additionally, you can install the Lightning Inspector, what is actually a Chrome extension that will display some new tabs and what will give you some more information, like, for example, the component tree, the fired events, or the server responses. And finally, you can also install a JavaScript linter plugin for the developer console. All right, now that we know the tools we can use and also how to set up the environment, Alba, please, can you give us some tip and trick for developing?
Yes, sure. So my first recommendation is to understand really well how the framework works, the framework architecture, and go beyond the basics. So let's say that a user navigates a page, an arbitrary page in Lightning Experience. The browser is going to request the app template.
Spoiler.
The app template is not more than an HTML file that is going to contain the dependency tree. Then the browser is going to request the Aura engine, which is a JavaScript library, and also the component definitions that were specified in the app template. Once the server has returned all of this, is the browser the one who is going to be in charge of rendering the DOM, the document object model, deserializing the components definitions, and rendering the HTML. What happens if in a future moment a user performs an action in the screen that needs some interaction with the server? The browser is going to make the server request, and the server is going to return some data, but just the minimum data in JSON. As you can see, this architecture is really different from Visual Force architecture, because in Visual Force, everything is rendered in the server and sent back to the browser. This means that most of the workload will be placed in the browser, and we will be able to build really performant and modern applications. This is a demo in which I've opened any arbitrary Lightning experience page. This is the Aura engine. I've opened the Chrome developer tools that Pedro was mentioning before, and I've set up a breakpoint in the function which is in charge of rendering the components in the browser. If I click on play and I pause and resume the debugger, you will see how the Lightning experience page is being rendered by the browser progressively. And this works for any Lightning experience page, because Lightning experience is also built on top of the Lightning Components framework. I said that the app template is going to come with the components definition and that the browser is going to request those to the server. But what's a component definition? A component is not more than a set of JavaScript files, HTML files, and CSS files mainly. Now. So it's really important that you learn JavaScript. If you want to work with Lightning components, JavaScript is the main technology that you are going to use. And a good idea is to start learning its differences with Apex, as for example, case sensitivity, asynchrony, etc. There are two main files in which we place JavaScript code, the controller and the helper. And a typical question from beginners is where to place the JavaScript code. Let's see this with an example. This is my controller. In a controller, you will be able to define functions that are going to receive always 3 parameters: component, event, and helper. That's something that you cannot change. And functions defined in the controller cannot be called from within the controller itself. But for that, the helper comes to the rescue. In the helper, we can define functions with any arbitrary parameters, and we can call those functions from the controller. That means that as soon as you want to create any reusable pieces of JavaScript code, you will need to place them in the helper rather than in the controller. What happens if you want to reuse JavaScript code among different components? Then you have 2 choices. The first option would be to use a static resource. You can include your JavaScript code in a static resource and use it in any component that needs it. The other option would be to create an advanced pattern called service component, for which one I leave you a link here. We have said that markup and JavaScript are part of the controller. But how do they interact between each other? Here I have another example. Here I have defined a component in which I have an attribute called myText. I'm just showing this text in the screen using the v value provider, which means view. And I'm also adding a Lightning button, which on click will update that text. We can see that in the controller, in which we are doing component.set and the value of the attribute. The final result will be something as the component that we can see in the right-hand side. So what's happening here, really? We are using 2 mechanisms to communicate markup and JavaScript. The first mechanism are attributes. Attributes have a bidirectional data binding with the DOM elements. This means that if the attribute changes, the DOM element will be refreshed. But if the value of the DOM element changes, the attribute will be refreshed as well. That's kind of what we're doing, setting the value of the attribute in our JavaScript code. The second mechanism are functions. You define functions in your controller or in the helper, as we saw before, and we can call those functions from within the markup using the C value provider. C means controller, because we are calling a function defined in the JavaScript controller. Another important part of the framework are events. Events allow me to communicate components between each other. There are other methods to do it, but events allow me to create an event-driven architecture in which components are going to be completely decoupled and which is going to allow me to build very flexible and scalable applications. If you already know CSS, applying CSS to Lightning components is going to be easy for you. You must just know two tips. So the first one is that CSS in Lightning components is going to apply only to the components in which it's defined. Normally, when you define the styles in the CSS files, you need to specify the this keyword at the beginning in any style. But what is this exactly? Let's see that with an example as well. Here I have defined a component that has a first level div with a class 1, and then a second level div. Well, this is not more than a class that the framework is going to add automatically to all my first level elements in the DOM definition of my component. And the framework does this so that the styles are only applied to my component. The other key thing is that you don't have to worry about cross-browser compatibility because properties will be translated to versions supported by all browsers. How many of you have heard about local service before? A lot of people here, great. So it's really important to understand the implications of local service when respects to Lightning components development. Local service is a security layer that Salesforce added so that our apps are safe against common vulnerabilities, as for example, cross-site scripting. But it has some implications regarding development. So first, when you interact with global objects as window or document or DOM elements, you are not really interacting with the browser API. You are really interacting with the local service API. And there are some differences. This is documented. You can check the component library and see what are the differences there. Second, local service is going to enforce JavaScript AS5 strict mode. This is really great because it's safer, but it has some implications too. If you want to use a third-party library that doesn't support strict mode, you won't be able to do it through the normal mechanism as a static resource. But the good news is that there's a workaround called Lightning Container that will allow you to execute that library in an isolated iframe. Third, local service will prevent you accessing the DOM from components that belong to a different namespace. This means that if you are using a component defined in a different namespace, you will be able to interact only with the component API. This is its attributes and public methods. Let's see this with an example as well. This is my component. My component lives in namespace C because I'm working in a developer OR. It's not a namespace OR. And I'm using two child components inside. First one is a Lightning button. Lightning button lives in namespace Lightning, and I'm using a child component which lives also in namespace C, which has some arbitrary HTML inside. I'm going to do two tests. The first test is going to try to find the button and change the inner HTML of that component, modify its DOM. The second test is going to do exactly the same, but for the component that lives in my same namespace. Summarizing, this is the component. This is the parent component, which lives in namespace C. This is the button component, which lives in namespace Lightning. And this is the child component, which lives in namespace C as well. What do you think that's going to happen here? So if we click on play, we are going to click on the first link, and we are going to receive an error. This is local service acting, because the button is living in a different namespace. However, if I click in the second button, the inner HTML is going to be changed. Okay, so now, Pedro, I have explained how to start developing from the beginning. But there are two mechanisms that will allow you to speed up your development. Can you explain them to us, please?
Yes, sure. Well, as Alba said, there are two mechanisms that Salesforce has provided for doing that. The first one is the Salesforce Lightning Design System, or SLDS, what is just a markup and CSS that follows the Lightning experience look and feel. And so it's basically code you can grab and use it in wherever you want. For example, in your own component or in an external website. In this way, you want to ensure that any of it, the component or the website, will follow the Lightning experience look and feel. And also it's important to say that SLDS gets continuously updated. Actually, it updates more often than Salesforce releases. And the second way for doing that are the base components. Base components goes a step further and encapsulate a markup, CSS, and behavior. And actually, it has several advantages in comparison with SLDS. For example, you can run base components with a single line of code and have advanced features built in. Like, for example, it has some components are responsive, has shared cache, or have accessibility features. Remember what Alba explained us regarding the local service? Well, namespace is important, and base components have a different namespace. The first generation of base components are under namespace UI, and those does not follow Lightning experience look and feel. But the new ones are under namespace Lightning, and those follow it. And if I say communities, utility bar, or Lightning action, well, all of this has in common that are containers. And a container is a place where you can place a Lightning component. And actually, not all components can go in every single container. So the quicker way for checking that is to go to the component library and check in the top right corner if your component can be used in there or not. And finally, ensure that your components fulfill your needs, and otherwise you can always go back to the SLDS. And well, those are the resources we have used for the creation of this session. We strongly recommend you to do the Lightning component super batch. It's really, really useful. You're going to learn a lot. We haven't had time to speak about the Lightning testing service, but it's basically a package you can download and install, and that will help you a lot by creating the JavaScript test. And also we have uploaded the code used in this session to a Git repo. So in case you want to have a look at it, you can do it through this link in there. Thank you very much. We hope you like it. Please do not forget to go to the developers keynote on Thursday. Thank you.
Thank you. Any questions? It's okay.